about 2.2? Any doubt from 2.2? Okay, fine, no issue. What about 2.3? Okay, still you don't have any doubt from 2.3. Okay, so then what about 2.4? Okay, let me, how many? Okay, 35. 2.4, 2.5. 2.6. Okay, then I guess you, okay, so it's then better if you don't have any doubt, then it's better you ask your specific doubt, then I'll take that.
Practice assignment, I have a doubt.
Sir, please explain equation of line topic.
I'll explain that, but okay, so before that I'll come to practice assignment also. Before that, is there any doubt from activity questions? So that is what my first thing I want to cover is basically I want to solve few activity question. In the meantime, I'll discuss the concept also. Okay, so if you have any doubt regarding concept also, I can explain that. So my first question is there any doubt from activity questions? Okay, no doubt, fine. Okay, so then someone asked from practice assignment. Which one you are talking about?
Sir,
Hello.
question number 3,
Yeah.
sir.
So
Question
actually,
number,
okay, sorry.
question number 3, right?
Sir.
So have you checked the solution?
Yes.
So this solution is visible, right? The solution file. So is it visible? I have said that solution file.
No, sir.
Okay.
No, sir, just the whiteboard.
Yeah, just a minute. Yeah.
Yes, it is visible now.
Yeah. So what is your problem with question number 3?
Sir, I'm not able to understand the approach to the question.
Yeah. Okay. Approach to the question. Okay. Okay. So the thing. Okay. So so the first thing is. Yes. So what is your problem with question number 3? Okay. So
Sir,
as
I'm
you.
not able to understand the approach.
Yeah. Let me tell you. So okay. Approach to the. Okay. So the thing. Okay. So as you can see, there is a table. Can you mute yourself? Like I'm getting some echo. So as you can see, there is a table. So basically, it says that in 1965, okay. So in the year 1965, the consumption of oil and coal, gas, nuclear, and renewable energy is given by these numbers. Okay, in some probably in some with this unit TWH unit. Okay, so these are the numbers that uh, that we consumed in the year 1965. Okay, and in the year 2015 we have consumed these many things in the year 2015, right? So and so what is the thing? It's basically it's given that in question number 3, it's given that a student assumes that a linear relationship between energy consumed and the number of years after 65. Okay, so that means you have a linear. So the number of so the total amount of consumption, it actually follow a linear pattern. Okay, in 1965. Okay, so here X is 1965, right? And the oil consumption at that year is basically 19,000. Okay. So this is a point. Okay. So this is in the 1965. You have this point, 1965 and 19,000. Right. And in the year 2015, so this graph basically represents the consumption of oil. Right. This graph represents the consumption of oil. And in the year 2015, we have this 2015 and 49,000. So as you can see, this relation basically it's follow a linear pattern. Okay, this is linear pattern means we are getting basically a line. Okay. So what you need to do? Suppose you want to know in the year 1980 what is the what is the amount what is the total amount that the world consumed oil. Okay, so for that what you have to do, you have to find the equation of the line. Okay, you need to find the equation of the line. And in the line if you substitute x equal to 1980, so that y basically will give you the total amount of oil that world consumed in the year 1980. Okay, and similarly, so once you have two coordinates, so as you can see for all these things, for oil you have 1965 19,000 and another point is 2015 49,000. So you have two coordinates. So once you have two coordinates, then for each of these energy you can construct a line. Okay, so for each of these energy you can always construct a line. Okay, so that is the whole idea. And so basically it's saying these are the graphs. Okay, as you can see, so we are getting certainly as we have 2 points for oil, we will get a line. Okay, similarly as we have 2 points for coal, so similarly 1965 for coal we have 2 points, right? 1965 and now 2015 38,000. Okay, so this point, so once I have 2 points I can create a line for coal. Okay, similarly for gas I have 2 points. Okay, for gas I have 2 points. Okay, so I can construct a line. Okay, and similarly for nuclear energy you can construct a line. So using this line you have to predict which of the following graphs represent all these lines. Okay, is it clear?
It is clear
One
now,
question,
sir.
Sorry?
Sir, yeah, sir, regarding this, can we do even without finding the line equation also? We can, because we are seeing the changes happen in 50 years. So then the next 10 years, we can find the proportion, right?
Yeah, correct. So the thing is, but to get the proportion, like you need the equation of the line, right? So how you can
No,
predict without?
I can minus, okay, for example, if you take the renewable, so 3000 minus 2000, so that is 1000 changes happen in 50 years. So that means every year, sorry, every decade, what do you call 200 is
So that is
increasing.
basically you are so indirectly you are basically you are basically giving the slope of the line. Okay, so
Okay, yeah.
so that is correct, but okay, so that certainly whatever you are saying it's correct. So you are basically computing the slope. Okay, so that is also fine since the rate of consumption is basically linear, so you can do that.
Okay.
Yeah. So that is how you basically solve this question. So as you can see, they basically represent the same thing. So in the graph, actually, what you can see, this 1965. So this 1965, that is the initial time. So that's why they are taking 1965 to be 0. Okay. So from all this graph, you can see it's all this line segment. They start with 0. Okay, so here some 0 comma a. Okay, they start from here. So according to that you have to predict which of the following graphs they actually represent the given data. Okay, is it clear now?
Yes, sir.
Okay, fine. Okay, any other doubt?
Yes, sir.
Yeah, so again, like so the thing is I can, so don't if you have any doubt, please unmute yourself and ask directly to me. Don't write in the chat box because I can't see the chat box regularly. Okay. Yeah.
Okay, sir. So this is Satya here. So my question is question activity practice assignment, week 2 practice assignment, and question number 10. So I'm finding difficulty in constructing a linear equation in this situation. I mean, for that question, can you help me?
Okay. Yeah, just a minute. Let me go to the question 9. 10, right?
Yes, sir.
This is your question, right?
Yes, sir. The Leo motorcycle one. Yes, sir.
Yeah. So, okay, so the first thing is, uh, you don't, basically to solve this question, you don't have to go for it. Okay.
Okay.
So, uh, so you don't really need the linear equation. Okay. So you simply, you can solve it without using anything. Okay. So, the problem, of forming this question is probably it's as you can see, this particular question depends on two things, right? The total cost.
Yes, sir.
Total cost. Okay, so one of the problem actually, you can't so you can't represent using two variables, so that is the problem. Okay, so the total cost, this is y, right? Let's say this is the total cost, and what you want, you want to write it, so the total cost depends on two things, right?
Yes, sir. The mileage, the total.
Yeah, so for how many days actually he rented the bike? Okay, correct, and the total
But there is
kilometer.
no limit. But there is no limit that Leo can ride certain kilometer in one day.
Sorry.
So there is no limit that Leo that motorcycle can be ridden that one day in one day.
There is, okay, so let me read the question. So Leo rents the motorcycle for 2 days. Okay, hence the rental company provides the motorcycle at Rs 50 per day with 100 kilometer free per day. Okay, so the additional charges after 100 kilometer are two. So there is, so what do you mean by the limit? I still don't understand. So you are saying basically this 2 days is the limit.
Yes, sir.
No, what actually I'm thinking, I'm thinking of to extending this into m days. Okay, some m is any arbitrary
Okay.
number. Okay, so as you can see, the problem is why you can't write it, why
In the
actually,
form
so
of linear.
linear equation. So the problem is the total cost depend on two things. Okay, total kilometer. Okay, total kilometer, right? So how many kilometers he traveled? Okay, as well as one more thing. Okay, total number of days.
Yes.
Number of days for which he rented the bike. Okay, so basically you need three variables. Okay, so certainly you can't do it using two variables. Okay, so that is the problem. So it's better, I will suggest you better directly. So certainly it's this thing don't require any
Yes, sir.
equation. Yeah.
Normal calculation is okay, but I was finding trouble that.
No,
So I
that is
can't.
what I am saying. Like you need three variables, okay,
Yes,
to
sir. Yes.
compute the total amount. okay, so total amount he has to pay to the rental company, okay, that is y. So you need two variable, you need x or maybe you need some z. Okay.
Yes, and okay, sir. Clear.
Yeah.
Thank you, sir.
Yeah. Thanks. Okay. Any other doubt from the practice assignment?
Excuse me, sir.
Yes.
Sir, actually, can you please show how to find sum squares error? Like,
That I will do. So my question is now, what is any doubt from the practice assignment? I'll come to that. Okay.
Question number 10.
Hello.
Question of, huh.
Hello, sir.
Question.
I actually have a problem in the question, in a previous question where, not this, above this.
No, someone asked me question number 12.
Okay, sorry.
Right? Is there anyone who asked me question number 12?
Yes, sir, it's me, Shubham.
Yeah. So what is your doubt in question number 12? Have you gone through this solution?
I'm able to understand the sense of this question. I'm unable to find the coordinates, sir.
Okay. Let me go through it. So as you can see, you have two boats, okay, and they are starting from the point A. Okay. Okay, so you have a this is the point where both the boats started their journey. Okay, and one boat is going to this point B. Okay, and another boat is basically going to this point C. Okay, following this line. Okay, so and one more thing is given. One towards ferry ghat B is going along the straight line y equal to minus 2x. Okay, that means I know the equation of this line. Okay, I know the equation of this line, and the equation of this line is what? Y equal to minus 2x, right? This is the equation of the line. And what is the next line? The other towards the ferry ghat C, along a straight line that is perpendicular to the path followed by B. Okay, so this is, so as you can see, this is a line. Okay, but we are only concerned about few part of the line. Okay, and also this is another line, and we are also concerned about a small line segment of that line. Okay, so this particular path, okay, so if you think this particular path has a line, okay, this line is basically perpendicular to this line. Okay, so this angle is 90 degree, right? So the next task is,
Excuse me, sir.
yes.
How
Yes.
you can say exactly it is 90 degrees?
Because it is given. It is given, right? This is line is perpendicular.
Okay.
Correct? Okay. So one thing is I know the equation of the line L1, and next thing is I want to find the equation of the line L2. Right? Can you find equation of the line L2?
Yes, sir, with the slope.
Yeah, correct. Because you know that slope of, if the slope of L1 is M1 and the slope of L2 is M2, then the
Yes.
product of their slope is basically what? Minus 1.
Minus 1.
And also so from here you can get the slope of M2, and also you know that this line passes through origin. Okay.
Yes, sir.
So now you know the line of equation of this line L2. Okay, so now you know equation of the line L1 and as well as equation of the line L2. Okay, so next what is given? Let's see. The river is 1 kilometer wide uniformly and parallel to x-axis, right? So the next thing is this river. Okay, the length of this river is 1 kilometer, and that means whatever this line is, this line the distance between these two lines is basically 1 kilometer, right? And this line is parallel to x axis. Then what will be the equation of this line, this one? What will be the equation of this line?
Sir, that part is I'm
Y
unable
is equal to 0, sir.
Sir, the
Not
same
y equal to
equation. Sir, the same equation as the like we get for the other thing.
see. Okay, let me tell you. See, the thing is, what is given? See, you have to understand that it is given that this length of this river is 1 kilometer, right? That means this distance is
One, sir.
one, correct or no?
Sir.
Then what will be the coordinates of this point?
So 0,
0,
1.
0, 1.
0, 1.
Right? This is the coordinate of this point, right? So now what you want? You want to find equation of this line, right? Equation of this line, maybe L3, and you know that L3 passes through 0, 1, and L3 is also parallel to x axis, right? Then what is the slope of L3?
Slope will
0,
be
sir.
same only.
0.
Slope will be 0, right?
Sir.
So now you can find the equation of L3, right?
Yes, sir. It is x is equal to 1.
Yeah,
1.
x equal to 1. Yeah, correct. So now you have equation of L1, now you have equation of L2, and now you have equation of L3, right? Now you can find, okay, please mute yourself. Okay. So, yeah. So now you can find the coordinates of B. So to find the coordinates of B, what you need to do? You need to find the intersection point of L1 and L2. Because L1 and L2 they intersect, sorry, L1 and L3. L1 and L3 they intersect at B. Okay. Then L2 and L3 they intersect at C. Okay. To get the coordinates of C, you need to find the intersection point of L2 and L3. Okay. So once you have coordinates of B, C, A, and as well as this point, let's say D, then basically it's distance formula to solve this question.
Sir, just a small question.
Yes.
We found the line equation for AC, right? Which is like getting y is equals to like something.
It
So
will be since this line passes through
yeah,
origins, and it will be some
yeah. So it will be like same, but the slope will be reversed or something. So
yeah.
we know the width of the river, right? So we know the y coordinate, that would be 1. So what if we put in the line equation of AC, if we put y equals to 1, and we know the slope, so we can get the x coordinate as well, right? For the C. So we know like something comma 1 would be C, isn't it?
So what you are saying? So how you can get the slope of this line? You are saying?
No, not slope, sir. We know we can write the line equation for AC, right?
That certainly you can do it, right? Because you know
Yeah.
the
So
equation of the line AB.
yeah. So, sir, what I'm trying to say, if we find the line equation of AC and the river is 1 kilometer width, I mean, we know the y value, right? So if we put in the line equation of AC y is equals to 1, we can get the x coordinate for the C point, right?
Yeah.
So we get the C point, and what if we do the same for like the slope, formula for like for the 2 points B and D, the slope will be equal as well as for the
No. For
point
what?
B and C.
No. I'm asking for what lines the slope are equal.
No, not slope equal, sir. What I'm trying to say, like line AB, this that is perpendicular to AC, right?
Huh.
So the slope of AB would be reversed
Yeah, that is
Like,
what he
like
said, right?
yeah. So what I'm trying to say, if I put y is equals to 1 in the line equation of AC, so we can get the x coordinate for point C, right?
Yeah, that is precisely you are saying the intersection of these two lines, right? That is how
Yeah.
yeah. So that is how
Yeah.
you find the. So when I said that this point is basically intersection of L2 and L3. So so how you are going to get it? So you just need to replace y equal to 1 in this in the equation of this line L3, right? Sorry, L2.
Okay. Oh,
Okay.
so okay. Sorry, sir. I just like just got confused. So you were asking that.
Yeah, so once you put y equal to 1 in the equation of this line L2, then only you will get the x coordinate of C, right?
Yeah.
Okay. And similarly, you can do it for this B also to get the
Yeah.
coordinates of B.
Yeah,
So,
exactly. Okay, sir. Got it. I
yeah.
just got confused. I was like, look, what is actually happening? Okay, got it, sir.
Okay, so any other doubt from, okay, this question is clear. First of all, whether this question is clear?
Yes, sir, it's clear.
Okay. Okay, any other doubt from practice assignment?
No, sir.
I have a doubt. Question number 6. When I solve this question, then I get in AB equal to BC is 1, 5 and BC equal to AC is 3. How could I solve it?
So which option you are talking about?
So when I solve this question, then I get AB equal to BC 1, 5.
So when you started solving AB equal to BC, okay. So the value of A you are getting are what? Hello?
So root under distance formula use.
Yeah, you apply distance formula, so that will give you some value of A, right? So what are the values you are getting for A?
1 minus 1. It means 2 square root under.
So if you solve, then you are getting A equal to 5 and A equal to 1, right?
Yes, sir.
So then it's written, right? If A equal to 5, then basically they will never form a triangle. Okay. So if A equal to 5, okay. So then basically if A equal to 5, these 3 points, they are basically in a line. Okay. So then they are basically in a line. Okay, this if A equal to 5, then you have 3 points, and these 3 points, they are basically in a line. So in that case, they don't form a triangle, right?
Yes, sir.
So that means they can't be isosceles, right? You want isosceles triangle, right?
Yes.
But in that case, certainly they are not. They will never form a triangle. They are basically in a line.
Yes.
So using that logic, actually, you can exclude this 5. Okay, so you can exclude that 5. Okay, A cannot be 5. Okay. So the only possibility is A equal to 1. Is it clear?
Yes, sir. Clear.
Yeah.
Thank you, sir.
Yeah. Okay, any other doubt from practice assignment?
Hello, sir.
Yes.
So can you tell in question 7 how will we find safe height?
No. Someone just before someone asked, like.
So question number 21.
Yeah, I'll come to SSC. Okay, just give me a minute. Someone actually asked me something about SSC, so I'll try to explain the concept, and as well as I'll solve this question. Yeah.
Okay, sir. Fine.
Yeah. Okay. Any other?
19.
So 15.
19, 15. Okay. is question number 15. Yeah, what is the problem in question number 15?
Sir, I just plotted randomly. I mean, like, rough plotting, but it actually, like, I messed it up.
No, no. So the thing is, so there is so you have bunch of lines. You just need to plot it according to the slope. So here basically what if you take b1 equal to 1, okay, so you are getting a line. So the line is basically s equal to, so in place of b you just need to replace 1. Okay, so x equal to t. Okay, so this is a line. Okay, so you can think of this line as y equal to x. So basically what you have s, so you have this is your s and this is your t. Okay, so and similarly, so this is one line. Okay, so the next one is let's say v2 is equal to -2. So then what you will get is s equal
to minus 2t.
Minus 2t. So again, you can think of this line as y equal to minus 2x, and so then simply you can plot it in the graph, right? So
Okay. So I actually again got confused. I thought that's the coordinate or something, or point of intersection or something.
no.
It was a slope or something.
Yeah. So basically, yeah. So this v1, v2, v3, they basically represent the slope.
Okay. All right, sir. Got it. Thank you.
Okay, so probably the next one is maybe 19, someone asked.
Can I ask something, sir?
Yeah.
I have a doubt in question number 7.
Yeah, just wait. So is there anyone who asked me question number 19?
Yes, sir.
What is your doubt here?
I got second option right. I mean, I don't know how to solve this exactly.
No, have you checked the solution?
No.
Then check it.
Okay.
Yeah, you check it. So you can check it now and let me know if you have any confusion in the solution. Okay.
Sure, sir.
Sir.
Yes.
So actually, in the practice assignment website, question number 19, option C was not mentioned as the correct answer.
Yeah, maybe you can check it now. Like I informed the portal team. They told me that they changed it. Okay, so if still you are facing the same problem, then please let me know, because in the morning actually I told them to change it.
Okay, sir. Sure. Thank you.
Any other questions?
Yes, sir. Question number 7, sir.
Question number 7.
Yeah.
Again, so before so have you checked the solution?
Sir, how did get the solution?
Okay, it's available in the portal. Okay, so if you go to the supplementary contents, okay, so there is a tab, practice assignment solution. You click on that tab and you can see week wise you have solution for practice assignment. Okay, so whoever asking the question, if you have gone through the solution PDF, then only you ask. Otherwise, please first go through the solution PDF, then still you are facing the same issue, then you can ask.
Okay. Okay, sir. Good.
Sir, just a small doubt clearing thing in that question number 7. It did say like the horizontal distance are 900 and 1800 respectively. So so once we get the equation, so we are just getting the y value for the respective x values.
Correct.
Isn't it?
Correct. Yeah. These are basically your x values.
Yeah, okay. Because in the solutions that they are just putting it, and like not actually clear. It's not totally clear. So that's why. So I had to like reconfirm.
So basically, so the thing is, maybe it's, I don't know, but yeah. So basically, this horizontal distance means they are actually taking the points on the x-axis. Okay.
Okay.
So 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 from here actually we are getting 2 points, 9,000 0 and 1,800 0.
So sir, for the respective points, you are getting the respective y value, which
Yes.
would be the height of the
Correct.
tower.
Height towers, yeah.
Okay, sir. Got it, sir. Got it.
Okay, any other doubt?
Sir, 9.
What is your doubt in question number 9?
What is the figure? I mean, what is the line FG? Where is G? I don't know, sir.
G is not given. Like G is some arbitrary point, and when you only know the y coordinate of G. Okay, and a coordinate is not given. Sorry, x coordinate is not given. Okay, so you just
Got it, the
yeah.
solution.
So some point is there. Okay, so G is some arbitrary point, and the coordinates are given. So certainly the coordinate of x coordinate of G is unknown, but okay. So some information is given regarding this. Intersection like this. So maybe what is the question? Okay, question is given that the slope of the line fg be 2 and the coordinates of g, then you have to find the value of a. So probably it's related to question number 8, I guess.
Sir, but where is G? I was quite confused with this.
Okay,
figure,
G is some random point. Okay, so it's certainly G is not in the figure. So G can be somewhere here. Okay.
Okay, thank you, sir. I've got it.
Yeah. Okay, any other doubt?
No, sir, not from my side.
Okay, so let's go back. I'll start discussing few concepts. Ashutosh Agnihotri, yeah.
Sir, how to find minimum distance between point and line?
Yeah, I'll come to that. Okay, just a minute. Yeah. Okay, so as far as I remember, one asked me about to discuss something about lines, and one more thing is SSC, some squared error. Okay. And I guess just now someone asked me how to get
Minimum distance.
yeah, minimum
About
distance.
to sigma
Equation
SSC.
of line.
Minimum distance. Okay. So minimum distance, yeah. So basically that is the formula, right? There is a formula for minimum distance, right? You just need to apply it.
And about to sir summation.
Sorry?
Summation. What is the summation?
What do you mean by summation? Summation is basically sum.
Yes, sir.
So what is that?
About SSC question.
Okay, so that is what I have written, right? So SSC. Okay, so before going into line, like, is there any specific thing you want me to discuss about line? Because I don't know what, because if you want to find, like, if you want.
2.49 points. Just an SSC sir question.
Sorry? Sorry?
So actually, I have a
to
doubt
approach
of the section formula, external section formula. I mean, where the line is intersected externally and.
No. We are not dealing with intersection of line externally. We are only concerned about internal intersection.
Okay.
Sir, point slope form.
Okay, so point slope form, right?
Yes, sir.
Yeah. So so that is basically the probably the easiest representation of a line, this point slope form. So what is basically is given? It is given that you have a point P, let's say x1. So you have a point x1 comma y1 in your line L. So P is a point in your line L. Okay. And one more thing is given. Okay. One more thing is given, that M is the slope of the line. Okay. So then how you can find out the equation of the line? Okay. So that is the main aim. So basically what? So this is your line L, right? This is your line L. You know P is a point, right? This is a point. So so if I pick any arbitrary point from this line, let's say this is an arbitrary point of arbitrary point in this line L. So what is the, then what will be the slope? How I can write the slope? How I can write M?
Y minus y1 upon x minus x1.
Y minus y1 upon x minus
x1.
x1. So once I have this, then I can simply write down the equation, right? So this is basically what? M into x minus x1 plus 1. So this is how you can compute the slope of the equation of a line if one point of the line is given, and once and also the slope of the line is given. Okay. So let me solve one example. Suppose you have a line. Suppose you have a line, and it is given that this line passes through, let's say, 2,3. Okay. So line passes through 2,3, and the slope of the line is -1. Suppose the line passes through 2,3, and the slope of the line is -1. So then simply you can find out the equation of the line. You just need to apply this formula. So this is what? This is your x1, y1, and this is your m. So then equation of the line will be what? Y equals to -1 times x minus 2 plus 3, right? So this will be the equation of the line. So okay, so just one thing I want to say. So there are so many forms of the line. So one of the easiest, at least for me, to deal with basically this slope intercept form. Okay, so you, whenever something is given, you always try to bring this into this. So once you bring this line in this form, then okay, at least for me, then it will be easier for me to solve most of the questions. Okay. Once you bring line into slope intercept form, then I guess it will be easier for you to solve most of the questions. Okay. Any other questions you want me to solve related to lines?
Sir, 2-point form, please explain.
2-point?
2-point form equation of line.
2-point form of a line. Okay, so that is.
Yes, sir.
Okay, so that is basically the same thing. So the idea is basically same. Okay, so you have a line. So 2-point, right? So if 2 points are given, then how you can construct the equation of a line? Okay. Suppose you know 2 points, right? You know 2 points. Let's say x1, y1, and another point which is x2, y2, right? So now suppose you have 2 points. So this is your line, and in this line you have 2 points. This is your P, this is your Q. Okay. So now if I pick any point from this line, let's say PQ, or let's say R. Okay. If I pick any point from this line, okay, then the slope of this line, slope of the line PR, right, is same as slope of PQ, right? Because PQ and PR, they are basically the same line. Okay, so the slope of this line is basically same as the slope of PQ, of the line PQ. So once I have this information, okay, once I have this information, then it's pretty easy for me to find out the equation of the line. What is slope of PR?
Y minus y2 upon x minus x2, x1. Y minus y1 upon x minus x1.
Y minus y1
upon x minus x1.
X minus x1, right? And what is the slope of PQ? X2,
y2 minus y1.
Yeah.
Y2 minus y1 upon x1 minus x1.
X2 minus x1. So once I have this, then simply what I can do, I can write y minus y1, which is basically y2 minus y1 by x2 minus x1 times x minus x1. Right. So this is basically your 2-point form of a line.
Equation.
Okay, sir.
Again, like so the thing is, yeah, so you
एक्सक्यूज मी सर, अगर एक लाइन कोई दिया हुआ हो और उसमें अगर इक्वेशन दिया हुआ हो y बराबर समथिंग, तो हम क्या x y कुछ निकाल सकते हैं?
Sorry, can you repeat? Suppose one line is given,
which equation is y बराबर 4x plus 9.
4x plus 9.
What is the coordinate x and y?
No, for a particular value of x, okay, value of x, you will get a particular value of y. So it's depend. So certainly you can't. There are infinitely many possibilities for x, and there are infinitely many possibilities for y. Okay, so you have to specify a value of x to get some value of y.
It's when it is dependent in each other.
Yeah, it's depend on the value of, see, it's a function, right? How, so see, the thing is, don't think line as some abstract object. You think of a line as a function. See, what is this y? This is basically f of x. What is this y? This is basically f of x, right? This y is nothing but it's f of x. If you give a value of x, so this is a function. Okay, this is basically a function. Okay, this if you give a value of x here, it will give you a value of f of x. Okay, for example, if you take x to be 1, right? So then f of x is basically 13. So for different values of x, you will get some different values of y. Okay, so that means so x equal to 1 and f of x is equal to 13. So that means, so if you take 1 comma 13, okay, let's say this is your 1 and this is your 13. Okay, so this is a point in your line. Okay, and similarly, if you take, let's say you take x to be 0. Okay, if you take x to be 0, what is the value of y, or
9,
or say f of 9, right? So then you will get some point of somewhere here, 0 comma 9. So then it's clear that this is basically your line. Okay. And see, the thing is, for each value of x, you will get a value of y. So similarly, if you take here, let's say -2, okay, if if you go here, then basically for this is basically minus 2 and what? If you substitute minus 2 here, then what you will get?
y1, sir.
1.
fx
Okay,
1.
this basically point represent your minus 2, 1. Okay, so for each value of x, you are getting a value of y. Okay, think of a line as a function. Okay, so you are basically when you are drawing this this line, basically you are representing all the points of this form x comma f of x. So this f of x is basically y. Okay, see this y coordinate is nothing but it's the value of the function at a point x. Okay. Is it clear?
Yes, sir. I got it.
Yeah. So any other doubt about lines?
No, sir.
Okay. So shall I then start SSC? Okay. So
परपेंडिकुलर लाइन क्या होगा सर? जैसे परपेंडिकुलर लाइन में कुछ डाउट है.
What is your doubt in perpendicular lines? Okay, let me explain this SSC, then I will come to that perpendicular line.
Okay, sir. Okay.
Okay, so let me take a direct solve a example, and along that example, let me explain you the concept.
I am a beginner for this chapter, sir, because I haven't read SSC or something.
Okay, fine, no problem. I'll start from the very beginning. Okay, so so the thing is, suppose the main idea is basically what actually in SSC what actually you are computing. Okay, so you have bunch of points. Okay. Suppose this is your two-dimensional plane. Let's say this is your two-dimensional plane, and you have a bunch of points. Okay, so let's say you have few points. This is a point, this is another point, this is another point. Let's say this is one more point. Okay, and this is one more point, let's say. So few. Okay, so you don't have to raise your hand. Simply unmute yourself and ask your question. So suppose you have a line. Suppose you have a line. Okay. Okay, this line, whatever this line is. Okay, so this is a line of the form. Let's say y equal to mx plus c. So what basically you compute in SSC, okay, in sum square error, what basically you compute this distance, the square of this distance. Okay, you compute square of this distance. Okay, you compute square of the distance. Okay, compute the square of this distance, and similarly you compute the square of this distance. So you compute square of all these distance and you add them. Okay, so that is basically the SSC for a line with respect to the given points. Okay, so that is the main idea in SSC. Basically you compute these distances. Okay, you compute this square of this distance, you compute square of this distance, you compute square of this distance, you compute square of this distance, and you compute Square of this distance. Okay, so the next thing is, suppose this point is A comma B. Okay, this point is A comma B, and the equation of the line is y equal to mx plus c. Then what is this distance? How I can compute this distance? So one thing is clear, if I project this point on x-axis, this is basically what? A comma 0, right?
Yes, sir. Yes.
So I know the coordinate of A and I don't know the coordinate of B. And what I want to do, I want to compute the coordinate, I want to compute the distance of AB. Okay, so, but one more thing I know, that I know the equation of the line. So now how I can compute the distance of AB. So to compute the distance of AB, you just need to know the coordinates of A and coordinates of B, right?
Yes.
You know the coordinates of A, right? But
Yes,
you
sir.
don't know the coordinates of B. How you can compute the coordinates of B?
Sir, by putting A's x value.
So basically, if you put if you put x equal to A, okay, if you put x equal to A in this line, okay, if you put x equal to A in this line, then basically this will give you the coordinates of B, right? What is this coordinate of B? Coordinate of B is basically what? A and MA plus C, right? This is your line, right? Y equal to mx plus c, and as I said, y is nothing but f of x, right? If I, so here in B, the x coordinate of B is A. So once I substitute x equal to A here, it will give me the y coordinate of B. So that is precisely MA plus C. Okay, and then the distance of AB is basically what? Square root of MA plus C minus B whole square. Okay, and that means I want to compute distance of AB square, okay, which is nothing but MA plus C minus B whole square. Okay, and similarly I have to do for all the points. I have some A, so I have some A, B, I have some C, D, I have some E, F, G, H, and Ij. Okay, I have to compute all these distance square and I have to add them. So that is precisely that whatever the value is, that will give me the SSC of this line with respect to this given data. Okay. So
what is the full form of SSE?
Sum squared error. So
Sum squared error.
Yeah.
Excuse me, sir.
Yeah.
Sir, why do we square the distance? Like we do not need the negative sign, but instead of squaring, can't we convert it into absolute values instead of squaring it?
So the problem with the absolute value, okay, so the thing is, one of the biggest problem with the absolute value is it's not, it's a non-differentiable function. Okay, so to compute maxima and minima, like when you will get maxima and when you will get minima, so for this kind of things you need differentiable function. Okay, see this problem with the absolute value, if you take f of x equal to mod x, so this is not a differentiable function. Okay.
Okay, sir. Thank you, sir.
So that is one of the biggest advantage of not taking this modulus. So instead of, we are taking square. So square is a nice function, it's a smooth function. So that's why you can easily find out maxima minima for square functions. Okay. Okay, so that is the idea. Okay, let me solve a few questions. So so you have bunch of points are given. Okay, so now you have bunch of points.
I have one doubt. So SSE is basically sum of all squares. So why do we need this?
Why?
Why do we need this type of squaring?
No, that will give you, see, that will give you a better approximation when you have bunch of data. Okay, so obviously you want to create some function that fits that data, right? Then only you can predict something about the future, right? So if you have collected few data, okay, and you want to plot a graph, so you want a best graph that fits all this data. And how you can find the best graph? Only by computing the error, right? By computing the error, then only you can find a best graph for bunch of data, right?
Right, sir. But sir, we have already drawn the line.
No, but we don't know whether this is a, so suppose if I will give you another line, okay, some y equal to m2x, sorry, m1x plus d, okay, and I ask, if I ask you which among these two lines is a best fit for these two for this given data, then basically what you have to do, you have to compute SSE for this line and you have to compute SSE for this line, and whoever gives you the minimum value, that is basically the best fit line for this given data. Okay, is it clear or not?
Sir, could you explain this SSE concept once again, sir?
No, I'll solve an example. After that, you can.
Sure,
Still you have any doubt. So the thing is what? Okay, so suppose, okay, bunch of data, bunch of points are given. Okay, so you have bunch of points and two lines are given. Okay, so two lines are given. You have some line, let's say y equal to x plus 2. Okay, and another line is let's say 3x plus 5, right? You have two lines. Okay, and the question is which line is a best fit for all these data. Okay, whatever these points are, A, C, this point, and this point, which line is best fit for all these data? So what basically you do, you try to find SSE for this line, next you try to find SSE for this line, and whoever gives you the minimum value, that is basically the best fit for the given data. That's why we're computing SSE. So in this case, so in this case I basically told you how you can compute for a given, for a particular line y equal to mx plus c. Okay, so this is a general equation of line. If I change the line, then again you can do it by using the same procedure. And so among all the lines, whoever will give you the minimum SSE, so that is the best fit. Okay, so let me first let me compute, take an example, then probably we'll get a better picture. So 3, 2, okay, 4, 5, 6, 7, right? So this is the data, and so that is, so this, as you can see, this x comma y. Okay, please mute yourself. So this, then we have 1, 2, 3, 4, 5 points. Okay, so first point is x1, y1, which is basically what? 1 comma 1. Okay, this is my first point. And this is my second point, y2, which is 2 comma 1. Okay, and similarly I can go on and on. This is x5 and y5, which is 6 comma 7. Okay, these are the points. Okay, and what I want to do, I want to find the sum square error for this data with respect to the line. What the line is y equal to x plus 1. Okay, so this is my y. Okay, so what is the sum square error? The sum square error is basically what? It's basically what I told you. It's basically y I, correct, yi minus xi, okay, minus 1, because if I substitute xi in this equation, if I substitute xy in this equation, what I will get? Xi plus 1. So that is what I am subtracting yi with xi plus 1. Okay, so the sum square error is this one. Okay, so okay, so then calculate. So first, what is y1 here?
1.
What is what?
1.
1. 1. What is x1?
1.
Minus 1 square. Okay. Okay, so let me remove this sign. And what is y2 here? 2. Right? y2 is 2. Right?
Y2 is 1, sir. X2 is 2.
Okay, sorry, correct. y2 is 1. x2 is 2 minus 1 square. And next one is y3 minus x3 minus 1. What is y3 here?
2, sir.
2 minus 3 minus 1 whole square. And next is y4. y4 is what? 5. So 5 minus 4 minus 1 whole square. So the last one is, I guess, 7 minus 6 minus 1 whole square. So then what is SSE? So what is the total value? So this is basically 1 minus 1, 0, minus 1, which is 1. The next one is, I guess, 4, right?
Sir, 0, sir.
This is 4, right?
Yes, sir.
This is 4. Then this is, I guess, again 4.
4.
Yes, sir.
This is 4. This is 0. And the last one is also 0. Okay. So 8 plus 9. So the SSC, the SSC for the line, y equal to x plus 1 with respect to this given data, okay, is basically 9, right? So okay, let me take one more example, and similarly for this same, okay, for the same given data, let me compute for a different line. Okay, let me take one more line. So instead of y equal to x plus 1, let me take y equal to x plus maybe let me 2x plus 3. Okay. So similarly, what I have to do now? So similarly, what will be the SAC now?
So the form would be like yi minus 2xi minus 3.
Correct. 2xi minus 3 whole square. And I is basically from 1 to 5. Because if I substitute xi, so if I substitute xi, then what I am getting 2xi plus 3, and I have to subtract this one from yi. Okay, that is what I am doing for all the given values. Okay, see this particular thing. Okay, so if I take this line y equal to so what basically this will give me y minus 2xi plus 3 square. Okay, so this basically gives me the distance. If I take this line, okay, if I take this line y equal to this line, let's say 2x plus 3, okay, this value actually will give me the distance between this one, between these 2 points. So that as you can see, I am doing this thing for all the points. Okay, so for all the points I am doing these things. Whatever the points are given, I am computing yi minus 2xi minus 3 whole square. So basically I am computing the square of the distance for all the points. Okay, that is the main idea. That is what I was trying to explain you over here. Okay, so as you can see, this is what I am computing. Okay, so similarly, if I try to compute, then what I will get now? If I substitute x, so what is x1 here? X1 is 1.
So what if we don't? There is no line given to us. We have to find the line.
Yeah. So for that is the problem. So for there actually you need differentiability. Okay. So that certainly you can't. Certainly that is not in your course. Okay. So when someone asks me like why you are taking this square. Okay. So if nothing is given, then probably you need differentiability. Okay. So obviously whenever we'll ask you SSE, then we'll give you bunch of data, and along with the data we'll give you few lines. Okay. Okay, so what will the SSE? Let's compute. So 1 minus
2
minus 2 minus 3 whole
minus
square.
3.
Correct. The next one is
1 minus 4. 1 minus 4 minus 3.
minus 3 whole square. The next one, I guess
2 minus 6 minus 3.
minus 3 whole square. Okay.
5 minus 8 minus 3.
Minus 8 minus 3 whole square. Then
7 minus 12.
Okay,
Minus
12.
12.
Yeah, correct.
Minus 12. Minus 3.
Whole square. Okay. So what will be the total value? So this is minus 3 minus 5. This is 16. This is minus 7. Yeah, correct. 36. This is minus 9 minus 2, 49.
49.
This is, I guess, 11 minus 36. And this is 15, 64. Okay, so here we are getting, can one of you tell me?
201.
201.
Correct. Okay, maybe correct. Okay, so let me take this is 201. So as you can see the difference, right? For the first equation, okay. So for the first equation, the SSE was what? 9, right? For the first equation, for y equal to x plus 1, the SS with respect to the given data, the SSE was 9. But for this one, with respect to the same data, the SSE is what?
201.
201. Okay. So for the second line, the error is more. Okay. The second line, the error is more. So if I ask you, so among these two given lines, which is a best fit for this data? Okay.
Line 1.
Then the answer is the first line, because for the first line I'm getting the least error. Okay, so for the first line I'm getting the least error. Okay, whereas for the second line I'm getting a huge amount of error. So that means my first line is a best fit. First line is a best fit. Again, the best fit depends on the given data. So here we have only 2 lines. Okay, see, if I give you, maybe if I add 4-5 other lines, then probably you will, for other 4-5 lines you may get different SSC, and again you have to conclude which among them give you the least error. Okay. So whether the SSC is clear, how we are basically computing the SSC? Is it clear or not?
Yes, sir, it's clear.
Okay.
Yes, sir, it is clear. Sir, can you give some real life example of SSC?
What do you mean by real life example?
Sir, like word problems.
Sorry?
Some word problems, sir. Like
What
you
is
know,
what is
so what problems mean like some real life incidents or events like for missing complaints and the femur bone stuffs and all those.
so the thing is, okay, so that you can't, so the problem is when you are saying real life problem, right? So real life problem, you can't do it by your hand. Okay, you have to go for some computer program. So in real life you'll never face a real life problem with 3-4 data. Okay, you will face with some 1,000 number of data, or maybe 10,000 number of data, and for that you can't do it by your hand. So then you have to use some programming. Okay, so this is sort of what I say. So this is basically, it's I'm explaining some toy example. Okay.
So basically SSC is for finding the suitable lines between one or two.
Yeah, so the thing is, so even so the same trick you can apply for quadratic equation also. Like you can, if I give you two quadratic equation, then also you can tell me, okay, which is the best fit. Okay, it's see, as you can see, the procedure is completely independent on the line. You can do it for any function. Okay, but certainly for this course we are actually, instead of dealing with any arbitrary function, we are only concerned about lines. Okay. So yeah, so
one thing,
but in general, so when you said like so in most likely in many places you actually you have to compute SSC for quadratic function. Okay, so many places linear, many data they are not they don't follow some linearity. So they approximate using some quadratic function, maybe some different function. So that depends on the data. But okay, so for this course actually we are only computing for lines. Yeah.
Sir, one thing you told that absolute value cannot be taken. So I didn't get it. Can you repeat that?
No, so the thing is, what actually someone asked me. Okay, so so you have a point, right? So you have a line here, right? So what actually we are computing? Okay. So we are computing. So this is a point A comma B, and this is another point A comma C. Okay, what actually we are taking? We are taking B minus C square. Okay. So someone suggested, why we can't take, instead of the square, why we can't take B minus C modulus?
Yes, sir.
So the problem is, okay, as I said, in generally so when you compute SSE, so in generally no one will give you line. Okay, so you have to start with some arbitrary line, y equal to mx plus c. Okay. Okay, in general. So when you deal with some real world problem, you have to start with some arbitrary line, and you have to find the value of m and c. Okay, so in that case you may get a function something like this, f of x equal to mod x. Okay. So when you have modulus function, this function is not differentiable. So when the function is actually not differentiable, it's really difficult to find the minimum value and maximum value. You don't have much rule. Okay, so you will see actually in maths 2 how for a differentiable function, so it's really easy for you to compute the maximum and minimum value.
Sir, here we are finding the squares that also gives us positive value only, and the modulus will also give us positive value.
Yeah, that is what I am saying now.
So why this is not differentiable?
That you'll study later. So
And what is the need to differentiate here? It is a summation of all absolute value only.
No, you need to find the minimum value. Okay, you need to minimize a function. So to minimize a function, you need differentiability. So that is what I am saying. Like so if something is given, so here actually so everything is given here. You know the line equation of the line concretely. Okay, suppose nothing is given, bunch of data are given, and I will ask you find the best fit for this data. So then what you have to do? You have to start with a line, right? Y equal to mx plus c, correct or not?
Yes, sir.
Then you don't know what is m and c, right?
Yes,
you
sir.
don't know m and c. Then if you take the modulus, what you will get? You will get, you will get y,
only positive number.
not positive number. You will get something like this, yi minus m xi minus c, right? This you will get. Okay, forget about rest of the part. Okay, for a particular thing. So now you don't know for what value of m and c the sum square error will be minimum. Okay, that you don't know. Okay, so you have to find that. So when you have a modulus sign here, okay, in that case, this f of x is not differentiable. So you can't find that. Okay, once the function is differentiable, then you can easily find out the minimum and maximum value of the function. So that is what I was trying to say. Okay, so it's always the square thing is always better than the modulus for SSC. So when you have a square, instead of modulus, you have a square, then this function will become a differentiable function. Then you can apply the tricks of derivative to find the minimum values. And once you find the minimum values, from there you can compute the value of m and c. Any other doubt regarding SSC? Am I audible?
Yes, sir.
No doubt, sir.
Okay, no doubt. Fine. Okay. Any other question you want me to solve regarding SSC? Probably I can solve it. Okay, fine. Okay, so then if you have any other doubt, then ask me. Otherwise, probably I'll stop the session. If you don't have any doubt, then
Some minimum distance between a point and line.
Sir, activity question 1.11.
Activity question
1.11.
1.11.
Activity question 1.11 in that last two questions.
Okay, I'll come to that. Okay, so I don't know, like, so the thing is, it's the perpendicular distance precise already mentioned in the lecture. So suppose you have a line like this. Okay, so suppose the equation of the line is given, sum of this form ax plus by plus c equal to 0. Okay. So, and you have a point here, let's say P, which is x1 comma y1. And what you want to find the perpendicular distance from the point P to the line L1. Okay, so the perpendicular distance is basically this one. Okay, so this is how you can get, you just, so the perpendicular distance. Okay, so this distance is your perpendicular distance. So this distance is given by this formula. What is that formula? This is basically A x1 plus
y1
B
plus c
plus C
y1
modulus divided by
a plus b का whole square.
not a plus b whole
Sir,
square,
a square plus b square.
b square. Oh.
But
So
it is not minimum distance formula. It is
sorry,
it is not minimum distance formula.
it is minimum distance formula from this point to this line. See, when you will get the minimum distance, when you are taking basically the perpendicular distance. Okay, if I take this distance, okay, then certainly this is not the minimum distance. Okay, because this is not perpendicular, this line is perpendicular. Okay, that's why this distance will give me the minimum distance. Okay, if I take some different angle, then certainly that won't give me the minimum distance. Since this is 90 degree, that's why actually it will give me the minimum distance.
So,
Okay,
but
so
minimum distance will be between middle and the line.
sorry,
Sir, it will not be a minimum distance. It
you
in
think
the
about
line.
you try to think about it. Okay, so what you are saying, why this, so you are saying this distance won't be the minimum distance, huh?
So can you drop
Sorry,
between the? So can you add point ABC in this triangle? Then
this
I
is
will.
not a triangle. Okay, what I am
No,
trying to
you
do,
may no, you make this I said
no,
give him point.
no, so see, this is a distance, right?
Okay.
This is a distance. So this PQ distance is obviously less than the PR distance, right?
Okay.
So that is what I am saying. So if you take this perpendicular line, then this particular thing will always give me the minimum distance. Okay. This distance certainly won't give me the minimum distance. Okay, because I'm not taking the perpendicular line. So once you take the perpendicular line,
If you want to
then
say something else,
Sir,
yes.
if the line is P and R,
Hmm.
if the line is P and R and point is Q, then how we will find minimum distance?
Then you draw a perpendicular line. Okay.
Yes, sir. I am asking.
Yeah, yeah. This distance will give you the minimum distance. So it's depend on the point and on the line.
Okay, sir. Okay.
Okay. Suppose let me. Okay. So it's better to do one example
Please
related.
explain this, sir, please, with example.
So suppose you have a line. Let's say y equal to you can ask, like, if you have any specific example on your mind also, we are ready to.
I do not have any.
Okay, let me take y equal to 2x plus 7. Okay, this is my line, and I want to find the distance between this line and say one more point. Let's say 1 and 11. Okay, so I want to find the distance between this point and this line. Okay, so this is what? This P is what? X1, Y1, right? This P is what? X1 and Y1. And what is this line? This line I can write it as y equal to 2x minus 7 equal to 0, correct? So now I just need to apply the formula. So if I apply the formula, what I will get?
-2 to 1.
What you need to write in place of y?
In place of y, we will write 1.
So what is the form? Ax1
In
plus
place of y, we will write 11.
11, correct. Then 2 times 1, right? 2 times 1 minus 7 modulus divided by what?
2 square plus 1 square.
2 square plus 1 square. Then what will be the result value? This is 2, 3. This is 1 by square root of 5. Correct?
Oh, sir.
So basically, so
11.
then,
11 minus, okay.
so then this is precisely the minimum distance from this point to this
2
line.
upon under root. It will be 2 upon under root 5.
Yeah.
Hi. There is an activity question which is similar to this. But, I'm not able to arrive at the answer that is given there. So you help me solve that.
So what is?
So that I can give you the numbers which are given there. The distance between, if I tell the point and the line.
Okay. Can you tell me the question number in
It's activity 2.12, question number 4.
2.1.
Yeah, 2.12, question number 4.
Find the distance. Okay, so it's given that you have a point.
Yeah, minus 1 comma 3.
Please.
The line is 4x plus c.
Yeah. Please mute it yourself.
With a focus on in-demand skills, making you ready for hiking jobs globally. Take your web point of programs with Times Pro now.
Okay, so it's given that so you have a line. So the equation of the line is what? So you have a line.
It's 4x plus c is equal to 0.
Yes. So this
They
is
have
the
given the
equation of
distance
the
to be
line.
3 by 2.
Right? This is your line. Okay.
Yeah, this is the line.
And it is given that minimum distance between this point P, which is minus 1 comma 3. Can you please mute yourself? I'm getting some noise of TV, I guess.
Oh, sorry.
So, so the distance between this point and this line, perpendicular distance, is basically what? It's given that 3 by 2.
Yeah.
Okay. So then we need to find the value of C.
So actually, this is a line that seems to be perpendicular to the x-axis. Because if you just convert it, x is equal to c by 4 or minus c by 4, it will be a constant.
Yeah, this is a constant. This is a line which is basically what? Parallel to
y-axis.
Y-axis. Yeah. So no problem. Is the formula you can apply the formula for any line, right? So what is this line? Basically, if you write in the general form, what is this line? 0 y plus 4x plus c
is equal to 0.
And it is given that the distance between this point and this line is 3 by 2. Now you apply the distance formula. Okay. If you apply the distance formula.
If I apply this distance formula, it is 0 minus 4 plus c.
Yes.
Divided by 0 squared plus 4 squared.
Correct.
Square root of 0 squared plus 4 squared.
So if you apply, what you will get 0 minus 4, correct?
Minus 4 plus c.
Plus c.
Divided by, divided by square root of 4 squared.
Yeah, 4 square. And it is given that this
is equal
distance
to 3 by 2.
3 by 2. Okay.
Yeah. I got the answer as 2, but I think the correct answer is 0. That's why I tried again, but I could not work out. So that's why I requested you to.
You are saying the correct answer is 0. Okay, let me do it.
No, I got the answer as 2, but the correct answer seems to be 0. So I could not get that.
Okay, let
Now,
me do it.
if we.
So,
the question is to find C.
Yeah, I understand.
Correct answer here is 10.
So if I multiply 4, what I will get?
Sorry.
It's 6, right? Correct or not?
Yes, sir. Yes, sir. 6.
Yeah.
Yeah. So, so then basically -4 plus C is either -6
or +6.
Or +6, right? That means C is either -2
or 10. Or 10.
10. Yeah. So what is there any problem with -2? If C becomes -2, is there any problem? I don't see.
No, I didn't know. I did a cross multiplication. I brought the 2 up there, and then.
So certainly this can be -2 also. Okay, I don't know, but I think C can be -2, C can be 10.
Distance cannot be negative.
No, C is not at the distance. Oh,
Okay.
C is basically what? C is here. Distance is 3/2. So if C is -2, what I am getting? C is -2, then -6, -2. So which is basically, if I take the modulus, this is 4, this is 6/4, I am getting 3/2. Yeah, this certainly this. Okay, it's given that C is a positive number. Okay, I missed that. Okay, where C is if you see the last question, find the value of C where C is positive number. Okay, so here C is negative.
Okay.
And C,
sorry, now I understand. Sorry, sir, I understood my mistake. Yes. When I did a modulus of -4 plus C, when I applied the modulus, I made it as +4 plus C. I applied the modulus on -4. Sorry.
So modulus means you have to consider both the signs. Okay. So,
yeah.
Yeah. So okay. So there was some confusion. So C, why? So now do you understand why C cannot be -2? Because it's given in the question that C is a positive real number. Okay. So in that case, we can't take this one. Okay. So this is the correct answer. 10.
Thank you.
Okay. Any other doubt?
So in activity question 1.1 on last 7 and 8.
1.11.
The weak one, sir.
Oh, weak one. Okay, I'll come to that. Oh, okay. So is there any doubt from?
Modulus can be reversed also, both sides.
Can reverse means what?
Means both side of is equal to, means you change the sign of 6 to -6.
What is it? If modulus of x is 3 means what?
Means value of x can be 3 or -3.
-3, right? So basically what I can write? This I can write as -4 plus c is -6 and -4 plus c is 6, right? That is what I have written. If mod of x is 3, then x is 3 or x is -3, right?
That case is capable for root values, na?
Sorry?
So that is capable for root values, like root x equal to 3, then it must be +3 and -3.
No, why it can't be apply? Why we can't apply here? I still don't understand your logic. Like you are just.
Sir, I'm asking that only.
Huh?
Sir, I'm asking that.
No, you can't. You certainly can apply for root also, but sir, that same thing you can apply for modulus also, right? If modulus of some number is 3, that means x is 3 or x is -3, right?
Okay.
So that is what I have done here, right? So this is my x now, right? So that means x. So what basically I have taken? So my x is -6 or my x is 6 plus 6. That is what I have written.
Excuse me, sir.
Yes.
Please explain the question number 11, sir, from practice assignment 1, week 2.
Well, have you checked the solution?
No, sir, I haven't. I did not understand.
Yeah, you check the solution. First you check the solution, then if you have still any problem, then ask.
From where, sir?
Its solution is available in the portal. Okay, is there any question from week 2? Otherwise, I can go to week 1. Someone asked some question from week 1. Okay, so someone asked me from week 1. So what is, can you repeat like 1.11 you have asked?
1.11, 7 and 8, 7th and 8th questions.
7th or 8th? Okay. So
Both together.
yeah, so basically both are related. Okay, let me. Yeah, so okay, so this should not be a. Just let me take photo. Yeah. So some function is given, right? So let me draw that function. So this point is 9,6. If I'm writing something wrong, you can tell me. This point is 3,1, I guess. Okay, let me take just slightly up. This point is -4,2, and this point is 0,9. Right? These are the points. Correct?
Yes, sir.
So what is the definition of domain? Like this, so the domain is basically set of all points for which the function is defined, right?
Yeah, yes, sir.
So from the graph, can you tell me what will be the domain of the function? For what values of x this function is defined?
The minus
-4
All
is
real
equal
numbers,
to
sir.
-4.
-4 to 9.
-4.
So for each values in between -4 to 9, I have a image, right? So if I take
Yes,
this
sir.
point, and then for this point A, I have an image here A, and something else is there, f of. So for all these points in this interval, I have an image for the function, right?
Yes.
So that means this is my, so, and if I take any point from here, then I don't have anything, right? For there I don't have any image. Okay, so that means the domain of the function is what?
-4
-4 to 9. Correct?
Yes, sir.
So
Yes, sir.
now what about the range?
So it's 2 to 6.
Maybe not 2 to 6. It's
so
should be 2
Ah,
to
yeah,
9.
it's small. Yeah,
2 to 9.
1
Okay, it's
to
maybe
9.
my picture is slightly confusing.
yeah.
1 to 9.
Yeah, so it's better to
1 to
draw.
6,
Yeah.
1 to 9.
6, that would be 1 to 6, I guess.
1 to 9, sir.
So now probably you may
Thanks, sir.
you may see why. So yeah, it's basically the mistake of my drawing. Okay, so as you can see, so how so the thing is how you decide from the graph which points are basically in your range. So my first question is whether 2 is in your range. Whether 2 is in the range.
Yes, sir.
Because for
Pre-image is minus 4.
so f of minus 4 is basically 2, right? So if I draw this one, so I'll get 2 here, correct? If I take the projection on a y-axis, then I'll get 2 here. Okay. And so here 1, can you tell me 1 is also in the range or not?
Yes, sir.
So similarly, if I take the projection,
Minimum.
so I'll get 1 in. So what you do, you try to project all the graph basically on y-axis. Okay, so if you project everything, okay, you get, so basically if you project everything, then basically you will get all the numbers in between 1 to 9, right? Between 1 to 9. That means the range of the function is basically 1 to 9. Is it clear now?
Yes, sir.
That's codomain only, no, sir. That's how you draw that as range.
No, it's range. Okay, so the thing is, it's not codomain, it's range. See, codomain can be anything, like it's up to you how you define the function. So if I define my function the same for a same function, the codomain can be different, right? So for example, if I take this function, so I can define my function f from R to R, and what is my function? X goes to x square. So here codomain is what? Your R. So R is my codomain. But instead of this, I can define the same function, use some different codomain. I define the same function R to R, not R, sorry. But I'm saying I'm taking 0 to infinity. Okay, the same function I'm defining, and x goes to x square. So as you can see, I'm defining the same function, but for the first one, the codomain is R. For the second one, this codomain is 0 to infinity. See, you have to understand that this domain and codomain, they comes free with the function. Okay, once you have a function, then certainly you must have a domain and codomain. They comes free with a function. Okay, range basically it's you need to find it. Okay, domain, codomain, they always they come with the function. Okay.
Thank you, sir.
Okay, sir.
Any other doubt?
Sir, in the same activity, 4th and 5th questions.
Have you tried 4th and 5th, or simply you are asking?
No, sir, I have tried.
Okay. So what? Okay, so tell me what you have tried about question number 4. So you have bunch of options, like what actually you, whether you have you got anything, whether this function is 1 or you have any specific doubt?
No, I don't know how to approach these questions. Should I just substitute the values for n and then check, or should I do something?
Yeah, you should. Okay, so can you tell me the question? Let me, f of n equal to
n plus 1 by 2 if n is odd.
plus 1 by 2
if n is odd.
N is odd.
N by 2 if n is even.
N by 2 if n is even. So what you want to find? We want to, okay, so certainly it's you have to check probably few points, okay, to prove something or to disprove something. Otherwise you can't guess, like so even if you want to prove something, then also you have to take few numbers and you have to check the values, okay, then only you will get some idea how to prove that one.
Okay.
And certainly if you want to disprove it, then you have to give some example, okay, let me take solve this. So if n is odd, then I'm getting n plus 1 by 2. Okay, so if n is odd, then n plus 1 is even, and if I divide by 2, then certainly I'm going to get so what is the what, so the function is from where to where, can I know?
N to N, sir.
N to n.
N to n.
N to n, right? So okay, so f of 0 is clearly 0, right? Right?
Yeah.
And what about f of 1?
1, sir.
1.
It's 1. What about f of 2?
1.
1.
So now I can clearly say that this is not injective, right?
Yeah.
Okay, so this is not injective. Now certainly I can, by just taking 3 values, I can clearly say that this function is not injective. What about surjective? What about surjective? Any idea? From the second line, you should able to tell whether this function is surjective or not.
If codomain and range are same, sir.
No, don't go into codomain and range. Codomain and range, yeah, that is basically you are saying the definition. Okay, I'm asking how to prove it. Okay, you are correct. If codomain and range are same, then the function is surjective. Okay, you are correct. But I'm saying how in this case, how you can prove that this function is surjective. Okay, and it's, if you understand this second line properly, then you should able to show that this function is surjective. See, what actually you want to show, for each natural number, you have a pre-image, right?
So, sir, if we take n as even, and we take like f of n is equals to y, which is n by 2, and n equals to 2y, and if we put f of 2y, that means we are putting 2y by 2, that means it's y, so we get a
Correct.
pre-image, right?
Correct. Yeah, that is what the idea is. So for example, if you, what you want, basically you want to show that for all the natural numbers, you have a pre-image in your domain. For all the elements in the codomain, you have a pre-image in the domain. So what you do, you pick any arbitrary number. Okay, suppose you take 5 in the codomain. Okay. Now it, by definition, it says that f of n is n by 2 if n is even. Okay. So what I'll do, I'll multiply 5 with 2. Okay. I multiply 5 with 2. So now you take 10, which is in the domain. Okay. This I am taking from the domain. Now if I compute f of 10, what I will get? What is f of 10?
5.
This is 10 by 2, 5. Right? That means this 5 in the codomain has a pre-image in the domain. Similarly, I can play this. There is nothing special about 5. I can play the same trick with all the natural numbers. You take 7, and what I want this 7, I want a pre-image for 7. Okay, and then what I have to take? I have to take 14. If I take 14, then 14, f of 14 is 7. And I can take same play with 8. I can take 16. Okay. Then for 9 also I can take 18. So for any natural number a, I can take 2a. So the f of 2a is basically 8. So for all the natural numbers in my core domain, I have a free image in the domain. That means this function is surjective. Is it clear?
Yes, sir.
Okay, I guess you have asked one more question also. Which one? 5 or 3?
5, sir.
Yeah, 5. Yeah. So what is your doubt in 5? 5 seems easy. Yeah, so what is your doubt here?
Is this session was recorded, sir?
Yeah, probably. Yeah, yes.
Okay, thank you, sir.
So you just need to substitute the value x equal to 1. You need to find f of 1, you need to find g of 1, and you need to compare which whether.
The first two options I'm getting it as correct, sir. It's
Sorry?
no, in the first option also I substituted and saw it, and the second option also I substituted. Both options seem to be correct.
Yeah. Well, you can try the same for third and fourth option, right?
No, sir. Fifth question, sir.
Yeah, fifth question I'm saying. See, this you have to apply the same procedure for all the options, right?
Yeah.
So if you can solve question option 1 and 2, then certainly you can do option 3 and 4, right? So what basically it's saying, see f of x is basically what? X plus 2 whole modulus,
Yeah.
right? And g of x is what? X square minus 4. The first option says that f of x is greater than g of x at x equal to 1, right?
Yes,
so
correct.
indirectly it's asking whether f of 1 is greater than g of 1 or not. What is f of 1?
Modulus of 3, which is 3.
3. What is g of 1?
Minus 3.
So then
f of x is first option is correct.
Yeah, so then similarly you have to do other option.
Oh, second option also is correct, sir. But I can only select one option.
Okay, you are saying, okay, so you tell this thing, okay, so okay, I understand now your problem. Okay, this is a MSQ, but it's coming like MCQ. Okay. Yeah, noted. I'll probably I'll change. Okay, let me check. G of x is greater than f of x at minus 2. What is g of minus 2?
0.
0. What is f of minus 2?
Oh, okay.
Huh?
0.
Then certainly g of x is not greater than f of g of 2 is not greater than f of minus. So then second option is incorrect, right?
Yeah, yes, sir.
What about third option? The value of f of x is greater than. So what is g of 3?
G of 3, 5.
What is f of 3?
5.
So then third option is also incorrect, right? It's certainly 5 is not greater than 5. 5 is equals to 5.
Okay.
So similarly, I guess fourth option, f of x is greater. So f of minus 3 is what? 1, right? And g of minus 3 is 5. Okay. So then certainly fourth option is also incorrect.
Okay. I made a mistake in the second option.
Yeah. Okay, so is there any other doubt?
Sir.
Hmm.
Sir, I have doubt in week 2 content of activity 11 first question, sir.
Can you mention it again? Activity
11.
2.11.
Yeah, yes, sir.
Hmm.
2.11 first question, sir.
Yeah. So what is your doubt here?
Sir, actually, I have to find the equation of the line which passes through a point 3, 4 and it should be perpendicular to the given line, sir.
Yeah. So what is the what is what
Sir,
will be the slope of that line?
yeah, the slope of the line would be -3/4.
Okay, just let me write. So you need to find the equation of a line L1, right?
Yes, sir. Yes, sir.
L1. L1 passes through which point?
3, 4.
3, 4 and perpendicular to?
To the line 3x plus 4y.
3x plus 4y.
-8.
-8.
Equal to 0.
So I know that L1 passes through 3, 4, right?
Yeah, yes, sir.
So if I know the slope of L1, then I can find out the equation of L1, right?
Yes, sir.
So what will be the slope of L1?
So it would be -3/4.
So I know that L1 is perpendicular to this line, right? L2, right?
Yes, sir.
That means slope of L1 times slope of L2 is what?
-1.
What is the slope of L2?
Then it would be 4/3.
4y minus 3x plus 8 y equal to -3/4x plus 8. So slope of L2 is basically what? -3/4, right?
Yes, sir.
Because this is what I have written, right? In slope intercept from y equal to mx plus c. So if you see, this is basically your m, correct or not?
Yes, sir.
So that means slope of L1 times -3/4 is -1, correct?
Yes, sir.
That means slope of L1 is 4/3, right?
Yes, sir.
So now you know the slope of L1 and also you know the L1 passes through 3, 4. Now can you compute the equation of L1?
Yes, sir.
Okay, fine.
Sir, actually the doubt is in the answer only, sir.
Okay, let me compute it. Okay. So let's say the equation of L1 is y equal to 3x plus c, right?
Yes, sir.
And since L1 passes through 3, 4, then 3, 4 should satisfy this equation. If I substitute 3, 4, then I can get the value of c. So if x is 3, then what will be the value? Okay, so this is 4/3 times 3 plus c. This is c, that means c is 0. That means equation of the line is y equal to 4/3x. It's not in the answer.
No, sir.
Yeah, it's in the answer actually. They have written in some fancy thing. See, what is the first line? 8x minus 6y, right?
Yes, sir. Yes, sir.
It is 0, right? You can write it as 6y equal to 8x, right?
Yes, sir.
That means y equal to 4/3x, right?
Yes, sir. Yes.
Yeah, so then it's there, right? So basically in say these two lines they are same. Okay, this line and this line they are basically same.
Okay, sir. Okay. Thank you, sir.
Yeah. Any other doubt? Okay, then I'll stop the session now. Okay.
Thank you, sir.
Thanks so very much, sir.
Thank you so much, sir.
Thank you all. Yeah.
Thank you very much, sir.
Thank you. Good night.
Thank you. Good night. Yeah.